Welcome everyone to the Ontology Summit 2020. Today is February 19th. Our summit theme is knowledge graphs, and the track today is the first session in the Why track. So it gives me great pleasure to introduce our speaker today, Matthew West. Matthew West is a longtime member of the Ontolog Forum. He's on the board of trustees of the Ontolog Forum. He goes back farther than I do in this forum, so much so that I think he's actually one of the, if not one of the founders, at least one of the earliest proponents of our community. Matthew is he's director of Information Junction and worked for Shell for many years and has been a very big contributor to our community for a very long time. So I'm really excited to hear what he has to say about this basic aspect of our whole community, which is, why are we doing any of this? Matthew.
Thank you, Ken. Yes, indeed. Why bother with information? I've picked up as a strap line from that, which Ken put on the page, from data to business value. Let's just a little bit more about me, in case you don't know. I had some 30 years with Shell. I was actually originally a chemical engineer, but I've been doing information management now for 30 plus years. And my interests are in information quality, data modeling, ontology, and master and reference data. I've been involved in some fairly big projects, like a $2 billion project to integrate Shell's downstream business across 130 countries, and developed Shell's downstream data model, and developed the master and reference data standards and architecture for that project. More recently, I've actually been a consultant with CPNI. That's the Centre for the Protection of National Infrastructure, national here being the UK, since 2017. And I'm advising on an initiative called Digital Built Britain, which has, amongst other things, the intent to develop over some time a national digital twin. Along the way, I've had some 25 years in standards development. Here are some standards I've been involved in. ISO 8000 is data quality. ISO 15926 includes a top-level ontology. ISO 18876 is an integration architecture. And then I'm still on the Policy and Planning Committee for ISO TC 184 SC4, which is industrial data that's been responsible for most of those previous standards. And I was the founding chair of Epistle, which back in the 90s was developing it. When I retired from Shell in 2008, I was a co-founder of Information Junction, and I'm the author of developing high-quality data models. Well, I talked about a national digital twin, and indeed, this is really going to be the case study I'm using for why bother about information. And what you can see here is within a public environment with national infrastructure, how it all interacts and how information feeds forward and feeds back around the place. And you can only really use information together and pull it together if it's consistent. And that turns out to be quite a significant challenge. So what's the sort of thing we're trying to achieve? Not all of you may know about the Grenfell Tower disaster, but this was a tower block in London which literally went up like a torch and killed some 70 plus people. And that happened because the tower had cladding on it that was actually flammable. And the next day, the question everyone wanted the answer to was which tower blocks have the same type of cladding as Grenfell Tower. And of course, there is no database that holds that information at the moment. That information is spread across local authorities, and most of it will be in PDF files. And it actually took about 3 months to answer that question. And they still weren't entirely certain that they'd found all the buildings that counted as tower blocks by the time they had finished. So the question is, what would it take to have all that information in databases which would be distributed? So they would be local authority databases holding planning data and building control data. And what would we need to do so that all those databases, or the data from them at least, was consistent, so that you could write a query that worked across them? What would that all take? And that's the kind of problem we're trying to see how to solve with the National Digital Twin Programme. So, well, we need to go back to information quality basics to start with how to do this kind of stuff. Why do we bother with information? We bother with information because it supports taking decisions. It supports and it's taking decisions that drives our business, so that it helps us to identify business opportunities. It reduces the risks of the decisions we make. You know, if you've got poor quality information, you're a lot more likely to make a mistake. It enables us to be responsive to change if we've got good quality information in a timely fashion. And by enabling better decisions, it enables us to increase effectiveness and reduce costs. Well, that's almost the answer before I've started. But what do we need to do in order to achieve that? Well, it turns out that it's really all about information quality and the critical properties of information to support taking decisions. So the first one is relevance. It does inform the decision being made. It's the needle, not the haystack. Clarity, you can actually understand what the information means. Accessibility, security, so it's easily accessible to authorized users, but not to unauthorized users. And of course, that's a key concern for a distributed national digital twin. Remember that you probably don't want to have in the public domain exactly where all the critical junctions are in your telecommunication systems, so that terrorists can just pick it up and plant a strategic bomb somewhere. Consistency, data is according to the same data model, reference data and identification scheme. All that amounts to the same ontology. Provenance, you know where the information has come from, who created it, and when it was made. Timeliness and completeness, these are two sides of the same coin. All the information being available when the decisions need to be taken. Accuracy, which isn't the precision of the number, but it's how close to the truth the data is. And then the cost, benefit and risk assessment. Is the cost of the data justified by the benefit it gives, or risk it reduces in decision taking? So if those are the key things that we need to attend to, and we have the ones in blue are related to the definition, and the ones in sort of brick red are related to the information values that you get. But it turns out that one of the most difficult of these, particularly on any scale, is consistency. Data is according to the same data model, reference data and identification scheme. Because amongst other things, your data model has to support all the data that you want to integrate and share. So from a security point of view, I mentioned security just before, you actually need to be quite careful. There's different layers of data. So there's data that's publicly available that everyone is authorized to see. The kind of stuff that comes up there in a national digital twin is the data submitted to regulators, for instance, is normally publicly available. data the user is authorized to access as a virtual database. So each user might have access to different data. They need to be able to see the data that they're authorized to see as if it were a single database, even though we know it's distributed all over the place. They might also have access to a register of data that's available that the user is authorized to know exists, but not actually authorized to see. And then finally, there's the data that the user isn't even allowed to have a sufficient security clearance for, that he's not authorized to know it even exists. So that's itself quite a challenge. How do you stratify your data so that you can control who has access to it? Now, you don't have quality without an information management system, and this is the outline of how that works in ISO 9000. Really, what people usually talk about is just the information realization. It starts from requirements, goes through information realization, and produces some information. And the quality management bit are the other bits here: the measurement, analysis, and improvement, the management responsibility, and the resource management. And just to give an idea of what's in there, here's what's in the management responsibility piece. And this is all about the leadership, actually having the right priorities set, information management policies, responsibilities and authority, management representation, which means people signing up to things, and management review. And the standard talks a lot about top management. It really means, the CEOs, the C-suite, have to have signed up to this stuff and have to have authorized it. And of course, the one before that is the resource management, which is making sure you've got the resources to do the job. And around the back, we've got the measurement, analysis, and improvement, which means you're measuring the performance of your processes in information realization, but also in management responsibility, but the ones inside the purple, not just the general processes of your business. Okay, let's move on. When you're looking at enterprise and industry integration, which is really what we're doing with a national digital twin. In fact, we're even looking at cross-industry integration. There are 3 dimensions. An awful lot of it turns out to be about asset lifecycle management. This is largely what digital twins are about. There's usually some physical twin, which is usually an asset, which is supporting some business processes. And you have it through its life cycle, from identifying the need for it through design, construction, operation and maintenance, and eventually disposal. And you have information that flows through that life cycle from one stage to another, supporting your processes. Quite a lot of stuff you buy in, so coming in from the supply chain, you have goods and services and information that comes with those goods and services. And then overall, you have your management and control across all of this, which might be across the life cycles of different assets, for instance, which was the example of the Grenfell Tower, where you're looking across a whole load of tower blocks, and your management and control and your analytics of performance. Now, when you want to integrate data from different places so that you can support your decision taking, the default turns out to be a point-to-point set of interfaces, and you can see here that gets quite messy, and I wasn't trying to make it particularly messy here. I haven't drawn this diagram with every node connected to every other node. I think most of the nodes are connected to about 8 other nodes. So with 25 nodes, you've got 72 connections with the way that's been done. If it was one-to-one, it would be around 300. And this is, but if you go hub and spoke, we're looking at 25 nodes equals 25 connections, because each just connects into two ways, of course, in each case. Connects into the hub, which is essentially, because this is we're talking about a virtual hub, which will be a messaging system, is just connecting to a common data model and reference data. And this is what that might look like in practice. So what we know you're not likely to be able to do is get everyone to change their corporate applications so that they conform to some common data model. And it probably wouldn't be very efficient if they did, because the kind of data model you need to be able to share what is more or less any information about anything, because once you're starting to look at the kind of scale we're looking at with the National Digital Twin, you are talking about just about any data about anything. You've got plenty of applications that are doing good stuff, they just don't have quite the same data model. So the first thing you have to do is publish it. And you publish it so that it is compliant with your foundation data model and reference data, or your ontology, and put that in a buffer database. Perhaps that's an option. You could just expose it according to that through an API, but that potentially exposes your corporate applications, and you might prefer to have a buffer database to hold that information. Then you've got an authorization layer, which works out who's allowed to access, manages who's allowed to access what information, and also provides the virtualization. And then it goes out through a messaging system and into, if you have someone querying across that, you have a querying buffer perhaps, where people are collecting the information they're going to use, and then that's going into some other corporate application. Remembering the Grenfell Tower, it's the one that's, it might just be a simple query that you're putting out, and it's coming out into some pivot table spreadsheet, which is going to show you who's got what and how much of it. Okay, and we've looked at, oh yes, I've talked about these things. Okay, what do we need to make that work? The core of what we need is what we're calling a digital framework. And this is what it needs to be shared by those that are engaging in the National Digital Twin. And they all need to use this consistently. So we've got the digital twin, so the information needs to be held as data. You need to be managing information as part of a quality management process. We need to have a foundation data model, which is being used to share the data, and the reference data, so that same classification schemes are used. And together these would be your ontology. There's an integration architecture, which was what I was showing on the previous page. Then you need to have a development methodology, so that the elements, you're going to need to be extensible, so that you can add to your foundation data model or reference data, because you're not going to be able to do this in one go. You would never start if you have to get everything sorted. You need architecture standards, so that deliverables will meet, so they can be part of the National Digital Twin, and also data quality standards, and particularly things like provenance, so that you actually know what the quality is. So that's the core of what you need to develop as a digital framework. And then there's a whole load of stuff you need to wrap around that. I'll let you take that in. I won't call them all out, but a few key ones are things like governance. There's no point having a foundation data model if you don't have a way of saying you have to use it. And if you don't use the foundation data model and you use another one instead, your data just doesn't get into the National Digital Twin. You have to have some authority that enables you to do that and say what is and isn't part of the National Digital Twin. Similarly, you need a strategy and operating model for how you're going to develop those pieces in the middle, and the plans and justification for doing so. Key performance indicators for your performance, developing and maintaining all this stuff. You're going to need to develop a community, training, support, an application portfolio that you have interfaces to, and so on and so forth. And it's interesting when you look at that digital twin landscape, how that turns up, because they turn out to be the information that you need to support digital twin quality, the data quality of digital twin, and also when you look at your quality management process, it turns out to be the information that you need to support these processes, which means that you can actually make the whole thing happen. And that's what I had to say. Any questions?
Okay, we have a few questions on the chat. Should we start with Ravi? Ravi was the first.
Let me just find the chat.
Can you hear me,
Yes.
Matthew and others?
Yeah, we can hear you.
You can? Good. So my question is, first of all, what is this digital twin concept? Is it
Okay.
like disaster recovery and
No.
business continuity?
Okay. Yeah, I tend to assume that people know about that now. Sorry, I should have said something. A digital twin is really any model or set of measurements about some physical twin that represent it in some way. So, and one of the things, there are two ways in which people talk about digital twins. They talk about digital models of physical twins, and they talk about data collected perhaps over Internet of Things type devices of some physical twin that give you a current state and indeed historical states of your physical twin. And they talk about connected digital twins when there is feedback from the digital twin to the physical twin, which is affecting actuation of something in the physical twin. But essentially, a digital twin is information. All information is about something. The something it is about is the physical twin. Therefore, the information is the digital twin.
So for the dynamic situation, how do you maintain the synchronization?
Well, that's just about taking measurements, and you take measurements as frequently as you need to be able to manage what's going on. That's about knowing the time constants for your processes, so that you pick an appropriate frequency of measurement.
And any connection with the knowledge graphs?
Ah, well, that's okay. I thought that, I hope that was obvious, but apparently not. If you come back to here, let me just share this one again. Where do I share? Again, I should have mentioned this explicitly. Oh, here we go.
If you tell us the slide number.
It's okay. I'm just going to put the slide on the screen here. If you look at this,
Yes.
it's all the data that's in this buffer database it will be a knowledge graph. And what's up here, the foundation data model and reference data, that's your ontology. I'm usually giving this presentation to a different audience, so they're not people that would know what a knowledge graph was, or an ontology for that matter. So.
Is that clear, Ravi?
Yeah. But I wish it was labeled, but it's okay.
Yeah,
Thank
sorry,
you.
I didn't have time to sort of systematically go through and adjust the language.
But I like to draw your attention to the two sides being the same in this integration architecture, And that is why I asked the question, is it like one site failing so there is a seamless rollover
No, no.
and
What?
business continuity?
Okay. All this means is that this is another business application. So here I might have one physical twin, and its digital twin, which is here, and here I might have another physical twin and its digital twin. And what I'm wanting to do here is query across both of them. That's what this is supposed to illustrate.
Hmm. Thank you.
So it's about how you integrate across knowledge graphs, which of course you can only do if they're using the same ontology.
Okay, Todd has his hand up.
Hello, Matthew.
Hi, Todd.
I don't know if you're familiar with some of the uses of the notion digital twin over here in the US, but in some domains, it's meant to be a representation of that physical entity with a high degree of fidelity. And
Yep.
the fidelity is supposed to be somewhat time independent, but of course, there's always a lag in updates. But I didn't hear that come across in how you referred to this notion of a digital twin.
Okay, well, that's certainly what I think the nice thing about digital twin is how many different definitions of it there are.
Okay.
And you just gave one of them. I tried to give three, and I think the one that I gave that's closest to what you described is a model of a physical twin. So, you know, a computational model that you can use to simulate a physical twin is one of the things that a digital twin that is being called a digital twin. And you have this other one which is about taking lots of measurements. Those seem to be the two main ones. But plus the specification of the physical twin is also a digital twin. So the design.
Well,
So there are just a large number of different sorts of digital twin. And what I notice in particular is lots of people wanting to say that what they're talking about is the only thing that is really a digital twin, but everyone's talking about different things.
Well, in your case of measurement, what does that entail, or how should we understand that? Again, in the context of the notion, however you want to interpret a digital twin.
Yeah, I've recently discovered, well, that's a connected digital twin. I recently discovered that I did my first connected digital twin in 1978.
Now, hold on. What is a connected digital twin?
This is where you are taking measurements,
right,
and then you are feeding back control to actuators in your physical twin that are taking action in the physical world. So
this is a control feedback loop of some sort?
Yeah, that's it. Yes, just a control system. And people call that a connected digital twin.
But again, is that assuming that there's some fidelity between the physical thingy and the representation in order to have the actuation behave as expected?
That's the whole point of taking measurements, is that your measurement tells you what the temperature is, say, or the flow rate is, or whatever it is at some point in your system, in your physical twin.
Okay, based on that seems to be a very expansive notion of digital twin, and in which case this notion of digital twin has been instantiated, or as you pointed out, existed for some time.
Absolutely, yes. I did my first one in '78, so you know, but that's one of the more popular versions of digital twin, by the way, in my experience.
Okay, I had not heard that. But one of the points you just made about the ability to simulate, I don't know if, well, that is a goal of a digital twin, I think, at least in some of the domains I'm familiar with. But that is sort of an entailment or something that you get once you have a decent fidelity of representation of the physical entity, that you can do simulations.
Well,
because
yes,
the simulations,
your model is in some sense a representation, and then you run the model to tell you about how
no. I wouldn't think that's the case. The ability to simulate behavior is different than the representation of the physical entity. But of course, you can't simulate the behavior of the physical entity without some representation to a degree
Yeah,
of
indeed.
fidelity of the entity that you want to simulate. So they're
Yeah.
different things. But what all they're saying is that you get the ability to run simulations or even think about having them if you have sufficient information, i.e. a decently represented model of your entity.
Yes.
Oh, okay.
Like I said, my experience is that the term digital twin has been given so many different meanings that you might almost substitute information for digital twin without much loss or without much difference really being noticed.
Okay. Have you seen that one of the reasons for having these things is to manage cost?
Well, of course, that would always be a reason for that. That goes right back to almost the first slide, which is what are you doing here? Why are we doing this? We're looking at reducing costs and increasing effectiveness. It's all about making better decisions, and you make better decisions to do those things.
Okay. Another aspect of digital twin over here in the US, at least, is that, again, this is in the context of system design, is that you want to have your design to be in such a representation that as the design becomes realized as physical entities, you can then keep expanding on it so that you effectively grow your digital twin as you develop your system.
Absolutely, and that's just what this is trying to show.
Okay.
As you go through the life cycle of your asset, you're building up information about your asset through its life cycle, a good deal of which may be coming in through your supply chain.
Okay. One last question I have for you. In one of your slides, you talked about the notion of, wait a second, it's on the chat here somewhere. Oh, you have a box titled or labeled physical twin processes. How are
Okay.
we to understand that?
Well, the physical twin processes are, well, they're these ones essentially. They're these life cycle processes. So there are two levels of processes. There are processes that are happening at the physical twin level, and there are processes that are happening and managing the physical twin, and there are processes about managing the digital twin. So the information about the physical twin.
So when you talk about physical twin processes, are you talking about management of that physical entity or the processes that the physical entity may realize itself, or both?
There are the business processes that are done. So it might include those processes which the physical twin is supporting, as well as those that are merely to manage its system, to manage and maintain it.
But not the processes that the physical entity itself may be realizing.
Yes, it does include those.
Oh, okay, okay. Okay, thank you. That's all I had.
Hi, this is Ram here.
Ram?
Can you hear me? Yeah. Actually, in terms of all this digital twin thing, it's a question of levels of detail here. Like what Matthew presented is at one level of detail, because that's a higher level abstraction in terms of a conceptual framework. But then you can go into a little more detail. Like for example, PTC has got this digital twin concept. That's Parameter Technology Corporation for. They have it for what is that for the CAD area.
You mean Ram? Excuse me. Did you say Parametric Technologies Corporation or?
Yeah. PTC.
Oh, they make product data management systems, among other things. Is that what you're referring to?
Yeah. But then they also have this digital twin concept, in which what they're saying is, like, let us say you have a Caterpillar product, and you take that. Excuse my talk because I have a little cough, so I'm trying to be careful. Slow here. I mean, I have so I can't speak very well at this stage, but anyway, I'm trying to. So the thing is that if you take the concept of a physical tractor, and then you have a virtual tractor in there. So the physical tractor is well instrumented. So whatever happens in the physical tractor, it'll be send messages to the virtual world, and you can actually monitor the whole thing. So there's a whole life cycle there, which Matthew showed, in terms of from the design to operations and management. Okay, that's a very low level CAD systems. Now, once that happens, So you have the actual model in your digital twin now. The only thing is that in Matthew's case, it's a much more bigger one, like a whole city out there. So you have this digital twin about this whole city. So there's a lot of issues around there in terms of information management of that thing. But in
That's
terms
right.
of knowledge graphs, where they come into picture is that the digital twin, now you have a whole lot of representational issues around in there. And knowledge graphs are a way to represent all the entities and how these entities are connected to one another and things like that. So I can
That's right.
view
That's,
that as a large graph out there, and any perturbations or any changes in the real world can be reflected in this knowledge graph, and you can do learning and all kinds of things. But I don't know
right.
whether anyone has done it on a massive scale, but at the conceptual level, the concept is good. Did I make it clear, Matt?
That's right. Yes, we're looking at we're doing this at the moment as a research project, and we're looking at what it takes to do that. We're hoping that it'll start in the new financial year, if we get the budget to go ahead with this, and then we'll start developing the pieces that you can see on here in particular. About how do we put together, because actually this authorization layer and virtualization, doing that is quite challenging, and also the authorization, because you might have heard of, I think it's IDAM, but that's for a reasonably centrally controlled environment, and we're going to need to do that on a distributed environment so that different people are authorized, so that each organization owns and controls its own data, but a particular user, might be able to see information across a number of organizations. And how you enable that is going to be one of the key challenges, I think, as well as the foundation data model and reference data stuff, which of course is going to need a top-level ontology of some sort, as well as domain ontologies in those areas that we go into. And
Hey, Matthew, this is
sorry.
Hey, Matthew, this is Mike Ritchie. I had a quick question for you.
Sure.
So the concept of digital twin, the physical, the virtual model, and the physical instantiation, and whatever process differences are between the two, I get that. I'm wondering if you're thinking about the human knowledge that sits on top of this system, and how to extract that digital, process knowledge, the know-how, the expertise. So it seems easy to have like a PTC kind of three-dimensional model environment where you extract all those parameters and you look at what you've actually built and you coordinate the two and you optimize against some kind of normal for your twin. That seems an easy part. A harder part to me is the intellectual capital of the humans and the systems that are moving that digital twin through a process, and then codifying, instrumenting, and then using some AI or ML to extract those features and optimize them. I don't know if that makes sense to you, but my question really is, okay, if you have a digital twin, and then if you're instrumenting for that human intelligence that sits on top of that digital twin environment, where do you see like AI and ML and suitability for machine learning with humans in the loop? Where do you see that in this architecture?
Well, somewhere else I've got another slide. Do you want me to pull that up? And I can show you the sort of full life cycle of everything to do with information. Let me get this one. I've got to swap sharing.
So if you think about this, like intelligent cognitive agents, right, that sit on top of systems and help guide humans in the loop. I think there's an MIT paper that I was just looking at, Professor Eric Borgensen, and he talked about suitability for machine learning, SML, and he talked about work task flow deconstruction, and how you'd go through task deconstruction, and what would you offload as far as codification for machine learning optimization, and what would the human do? And then a system like this within your architecture, where you're thinking about the digital twin, it seems like one of the challenges is in codifying that human knowledge and then having an ontology that maps the business processes and then having some algorithms that come through that to surface these patterns. Are you looking into that at all?
Well, this is a sort of, can you see this information life cycle? It should look like a bare graph at the moment.
Yeah.
So this is just a sort of a full life cycle of what goes on. So you need to start by identifying your business processes and what are the knowledge requirements for that. You need to specify your business process and identify your information requirements to support particular decisions. Then you need to specify the detailed facts and content and quality you need to produce that information. You need to go out and acquire the facts as you're executing business processes. You need to validate them, store them, make inferences, acquire that as information, publish it. You need to find that, support executing a business process so that you use it. You might cause you to update it. So this is all the sort of life cycle going across here for your information. You might dispose of it. You might archive it. That's the information level. And here we are at the knowledge level. You're starting to see some patterns in your information. So I haven't got all the fancy stuff on here yet. So you acquire some knowledge, you publish it, you find it so that you can use it again. In using knowledge, you acquire more knowledge, and in acquiring knowledge, you identify a need to transfer it, and you just check that your actual knowledge that meets your knowledge requirements. Again, archive and dispose. Oops, let's go back, because what you can't see on here, on another version of this diagram, I drew some circles for some current buzzwords. So down at the bottom, acquiring facts, the current buzzwords for that is Internet of Things. In the middle, the sort of acquiring and publishing information is about digital twins. And up the top here, acquiring knowledge in particular is about data science and artificial intelligence are the kinds of things that people are talking about up at that level. Does that say something to you?
It does. I think I'm maybe take the conversation offline and if you're interested, talk about this later if it's not of interest to the participants here. But it's in the codification of that human knowledge, and then in the storage of that knowledge on top of the digital twin, and then the use of AI and ML as a intelligent tutor. You know, I mean, if you think about the computational power of a good federated database with codified human knowledge, then you could have an agent interacting to shift that mid-cognitive stuff over to a database. And so the codification of that knowledge is really, I think, the biggest challenge that we're wrestling with right now.
Yeah, I agree. And that's the kind of stuff that I normally expect to find out, well, partly in ontologies and partly in models in the engineering sense of things, so that you can simulate what goes on rather than having to do experiments all the time, physical experiments all the time. Okay, any other questions?
Yes, I have.
Hi.
Ravi here.
Yes.
Ken, do you hear me?
Yes, Ravi, go ahead.
So you kindly slide where you were. If we just listen for a minute,
I'm sorry, you're breaking up, Ravi.
Okay, if we imagine that we are going to duplicate slide 24, namely duplicate the knowledge information cycle. This kind of exercise was done in Delaware, where in case of disaster, a recovery site was put in another state with similar human capabilities. In
Right.
case of Mike Ritchie, the question was automating that expertise, but there was physical expertise duplicated
Yes.
from one state to another. So that was akin to something like digital twin.
Yes, that business continuity level of addressing using digital twins is a different one. That's making sure that you can recover when something goes very seriously wrong. I know Shell used to have plans for surviving nuclear war as an organization.
Wow.
Yeah, that was in the 60s and 70s in particular. And some of
And
that.
what prompted?
I should think the Bay of Pigs had quite a lot to do with it, and the Cuba crisis.
Thank you.
But it's just, what could go wrong? What would we need to be able to do if things did go up in smoke in a big way? And how would you survive and carry on with legitimacy? So for instance, in those days, there wasn't so much information in computers, and Shell had a warehouse, a bunker in darkest, deepest Africa, where critical documents were held, for example, that would be expected to survive a nuclear holocaust and would give, the necessary starting point in terms of information for business to pick up and carry on again from scratch.
Interesting. Thank you.
Yeah. Yeah, it was a bit of a surprise to me when I heard about it.
So, Leah?
Leah, yes. Hi. I saw that Jana had raised her hand quickly, so maybe she had the same question. In the chat, she made a really interesting point about where the line of physical begins and ends. And, if you're thinking about something like a nation that has all this infrastructure, maybe the bounds of a country that has all this infrastructure, how do you define that within, the digital twin model? And I was wondering if there's anything that you had seen in your work where maybe there was, like, you bumped up against a line of, well, I'm not sure if this physical entity that seems like it's physical could be represented within the digital twin model that you've been describing. I hope I didn't take away your question, Janet.
Well, there isn't anything that isn't physical, would be the first thing I would say. But remember, I'm a four-dimensionalist, so I would say that. So that's not really a problem. But I'm not. But there's not that. Where you draw boundaries on your physical twin strikes me as being reasonably arbitrary. So if we think about the electrical power system for the UK, you could draw the boundary at the border of the country, but we actually get quite a lot of our electricity from France's nuclear power industry. So isn't that part of our, shouldn't that be part of our physical twin as well? It's a choice that you can make. You can say, well, here's the boundary and we import and export across it. Or you can say, yeah, of course, we get electricity from those nuclear power stations. We should count them in too, in some sense.
Okay, thank you. I'm guessing Janet might have follow-up on that, or
yeah.
more.
Thanks. Following up. Yeah, so I agree with you that everything has physical characteristics, so that nothing is excluded, but it's not, a nation is not purely physical. And I'm afraid that a new optimism about how simple this is going to be is being smuggled in under this digital twin metaphor, digital
Oh yeah.
twin, physical
No,
twin.
no, no. There's
Um,
nothing simple here.
right, right. So you're really just saying the target of the model. You're
Well,
saying,
no. If we look back at let's just come back to I want the other presentation. Here we go. Can you see the distributed integration? Oh no, it's the wrong one. I've got to stop sharing that one and start sharing the other one. There we go. If we look at this bit here, we're looking to produce this digital framework bit here.
mhm.
We're not actually producing this national digital twin. That's something that'll come along maybe over 20 years, and it'll only be
Right.
partial. It'll be the bits that are worth sharing. But what this gives you is the capability to do that sharing.
Right,
And
and I
then,
appreciate that this is a very competent and sophisticated and experienced way of putting this together. What I, but maybe you could address this by bringing in your insight into previous efforts to do something similar that have failed, and what is different now.
okay. Well,
I'm afraid, it's not just the new metaphor of digital
yeah.
twin. Oh, anyway, go on. Okay.
No, that's fine. I think I've been working on this problem for about 30 years now. And you're right. There's even another. What happens is that typically people produce their data model and reference data for a particular set of requirements that they can identify. And everything goes swimmingly until someone comes along with some new requirements that are absolutely vital, which usually takes about 18 months, by the way. Then the problem is that in order to meet those new requirements, you have to make typically some important changes to your data model and reference data, not just add a bit to it. And that means you've then got a high cost of reformatting all your data according to this new data model. And of course, only some people are going to bother doing that, because for a lot of people, they didn't have this new requirement. So they stick with the old model, and you immediately get consistency when that happens. And you see that with all kinds of data standards that are out there. One I can think of in particular are the IFCs, of which there are multiple, industry foundation classes which are used in construction, which there are multiple versions of, and really not very many people are using the latest version. So you can't integrate data across all the people that are using the IFCs because it's not consistent. The data model they're using isn't consistent across all of them. Then the big thing is that you want to have your foundation data model and reference data so that it's always backwards compatible, so that you might want to extend it, but you never have to change it, if that makes sense. And that puts particular quality constraints on how you're going to do that. And in particular, it means you really don't have much choice but to use some kind of top-level model, top-level ontology, life, the universe, and everything, so that anything that you come across is going to fit into some framework. And then the problem is that although top-level ontologies are supposed to deal with life, the universe, and everything, actually most of them don't. So it's about constructing a top-level ontology with sufficient capability, that you've got a good chance of being able to be extensible for some considerable period of time.
Excellent. Yes, I think that really gets at a core issue for our whole effort here.
If you want to know how to do that, I wrote a book called Developing High Quality Data Models, which goes through at least a partial answer to how to do that. And indeed, it's that work that we're picking up on at the moment, or I'm expecting we will pick up on, perhaps I should say.
So Mike Bennett has his hand up.
Hi, Mike.
Hey, Matthew, how you doing?
Very well, thank you.
Good. So this entire conversation is in about digital twins. So ignore my earlier question, but just one last comment on the digital twin matter off the back of Janet's comment. I think you do need to be able to have digital twins for things like nations, corporations, sure, and so on. The thing that is shell that crawls out like a certain well-known insect after the nuclear holocaust is not a physical thing. So there's implications.
Well, that's
here.
where I disagree with you, Steve, Mike, because I would argue it is a physical thing.
Well, this is my point. This is the point I'm coming to before you disagreed with me, was this. There are implications for the ontological stance of your top-level ontology. You can't just pick any top-level ontology.
Indeed.
So, for example, you would disagree perhaps with BFO, which I usually take issue with, in that BFO allows for social constructs to themselves be regarded as real things. Now, most of my work, I tend to prefer conceptualist ontologies because they allow you to talk about risks and plans and so on. But it may be that the digital twin, you have to be able to say that there is a certain constraint in your ontological stance of your chosen top-level ontology that it must be realist or it must be physicalist or four-dimensionalist. But these are perhaps not answers right now today, but questions that are important to frame before you can even select the right top-level ontology for digital twins.
Yeah, I wouldn't get too excited about digital twin in as much that I'm quite comfortable that you can have a digital twin of a process, for instance, or have a digital twin of anything in the in the world. And right. I'm quite happy that you can have a digital twin of risks. That's fine. It's just a way of talking, and it's as near as as near as possible a synonym for information. So that's something I wouldn't say.
I'm inclined to disagree, because I think that my normal kind of default position of liking a conceptualist ontology, because it is pure information for plans and hazards and so on, for something to be a digital twin, I think needs to be real in some sense. It needs to be a twin of something real, and then the question is whether the real includes social constructs or just the substrates on which social constructs are expressed and so on.
Well, again, this is the difference between our stances is really about our ontological proclivities, Mike. So
my point is I'm actually going against my normal ontological proclivities, because I think that for digital twins you probably should use something like BFO, which I normally resist in every other business context.
Yeah. Okay, well let's just take that head on, because one of the problems with BFO is it doesn't allow things to exist in the future, whereas with digital twins you're always talking about plans and things like that.
Okay, so you can have a digital twin of a thing that isn't expressed in reality because it is. That's interesting, right?
Well,
I think for any given project, one probably has to start out by formally documenting these framing questions before you even start.
Sure, absolutely, and I think that we rapidly reached the point where, because we're unquestionably looking at services that would be delivered to society. We're not just looking at assets, but the services those assets are used to deliver. So we're looking at passenger journeys and things like that, for instance.
Right.
Cross-modal. It's really very broad, the
So
way it's turning out. And,
you need a
and
conceptualist top-level ontology then.
no, I need a 4-dimensionalist one.
For example,
For example.
now you're retreating to one proclivity, whereas what I'm trying to do is flesh out a methodology that embraces
Oh, okay, no,
the
that's fine.
best of each of the things for their most appropriate use, whether it's BFO or
indeed.
4D ideas or Dolce
Yes, no.
or whatever.
Yes, no, and I agree, and we will be going through a process that works that stuff out.
Good.
And we'll be using, you know, ISO 21838 to help us do that, part 1.
Good, good.
Because that
which limits you to BFO and has its own challenges thereby. For now, at least.
Yes. Yes.
Ideas is off on one side of BFO, and Dolce and all my other friends are off on the other side of BFO. We need to get them all into the ISO thing as parts 3, 4, and 5 as soon as we can.
It would certainly be helpful to do that kind of thing. Yeah.
Can't be anything, find a budget for it. Yeah.
Well, exactly. You know, who's going to pay for it is always the problem.
Yep.
Yeah.
Great. So on that note, I think we can adjourn. Thanks to everybody, especially to Matthew, for a very insightful session. Covered a great deal of ground. And so I would invite all of you to join us next week when Anirudh Prabhu from RPI will be speaking in the How track. The title is Insights from Knowledge Graphs. So thanks to everyone. See you all next week.